Hello everyone, welcome to the equation web. Today we will be doing another trig problem, so let's start with the question. So today's question will focus on trigonometric angle addition formulas. So stuff like cosine A plus B, sine A plus B, tangent of A plus B, stuff like that. So today's question is, find the sum of all distinct solutions if x is between 0 and 2 pi, not including 2 pi, of the equation cosine 3x minus 4 cosine 2x plus 3 cosine x equals 0. I'll give you guys some time to try to solve this by yourself. So we're going to try to break this equation down into just normal cosine, so not cosine 3x, just cosine of x. So in order to do that, we will recall the cosine A plus B formula, which is cosine A cosine B minus sine A sine B. So cosine 3x is just cosine 2x plus x, so we can plug that into our formula. So when we plug that into our formula, we get cosine 2x times cosine x minus sine 2x times sine x. This can definitely be reduced down to more like just cosine x's, so we're going to do that in the next steps. So we know that cosine 2x has multiple different formulas, you can say. So we're going to use 2 cosine squared x minus 1 as cosine 2x, even though there are multiple, since we want to get this equation down to only cosine x's. And then for sine 2x, there's only one, which is 2 sine x cosine x. So then we'll just distribute everything, and we'll get 2 cosine cubed x minus cosine x minus 2 sine squared x times cosine x. Next, we know that sine squared x plus cosine squared x equals 1. And from that, we get that sine squared x is equal to 1 minus cosine squared x. So we can plug that in to get more cosine x's instead of sine x's in our equation. And finally, we can distribute everything, and we can combine like terms to get our final answer, that cosine 3x is equal to 4 cosine cubed x minus 3 cosine x. This is our simplified form of cosine 3x, so that we can put it into terms of just normal cosine x. So then we can plug that into our original equation. So we get that 4 cosine cubed x minus 3 cosine x minus 4 cosine 2x plus 3 cosine x is equal to 0. And then the plus 3 cosine x and minus 3 cosine x cancel. So then we just get this final expression. From there, as we know before, cosine 2x is just 2 cosine square x minus 1 in terms of cosine x. So then we can plug that in, and we get this, which is 4 cosine cubed x minus 8 cosine square x plus 4 is equal to 0, which will be our new equation. From there, let's say that y is equal to cosine x. We can plug that into our equation, and we get 4y cubed minus 8y squared plus 4 equals 0. This makes it a lot easier to understand this cubic equation and may simplify it in later steps. So then we can rewrite our equation as such. It does look a little daunting, but I assure you it's not that complicated. So first, we factor out the 4, and we get y cubed minus 2y squared plus 1 is equal to 0. And then we rewrite minus 2y squared is minus y squared minus y squared. And then we just add plus y minus y, and then we keep the plus y. This makes it really easy to factor this. Then we factor out y squared from the first group, a negative y from the second group, and minus 1 from the third. As you can see, there are multiple groups of y minus 1 times something. So from there, we can just factor out a y minus 1, and we get y squared minus y minus 1 as our other factor. So this is our final factored form of our cubic equation. So 4 times y minus 1 times y squared minus y minus 1 is equal to 0 is our new equation. So from there, we set both of the factors equal to 0. From the first one, we just get that y is equal to 1. For the second one, we're going to have to use the quadratic formula. And from the quadratic formula, we get that the solutions are 1 plus or minus root 5 over 2. From there, we can substitute back our original value of y, which is cosine x. get cosine x is equal to 1, which the only value that we have in our interval is 0. And then cosine x is equal to 1 minus root 5 over 2. We don't do 1 plus root 5 over 2 because that would be greater than 1, which is greater than cosine x's amplitude, and that wouldn't be possible. So we take the arc cosine of both sides, and we get that x is equal to arc cosine of 1 minus root 5 over 2. And then we can also do 2 pi minus that value, because cosine is a repeating function. And in our interval 0 to 2 pi, we must have two places where cosine is either positive or negative. We don't know if our value right here is positive or negative, but it doesn't really matter in what we need to do. So we need to find the sum of the distinct solutions of this equation. So let's add all of these up. So 0 plus arc cosine of that plus 2 pi minus arc cosine of that. And the arc cosines cancel each other out, which is really good because those are the complicated part of this. And 0 plus 2 pi is just 2 pi. So the answer to our question is 2 pi. So our question was, find the sum of all distinct solutions where x is in between 0 and 2 pi, not including 2 pi, of cosine 3x minus 4 cosine 2x plus 3 cosine x equals 0. The answer to our question is 2 pi. Thank you for watching, and make sure to like and subscribe.